go. All right. Sorry, just trying to get one other recording going as well. Okay, so my name's Jamie McCutchen. I am the founder of Rymar Waterworks. I'll cut the video on here for just a second to get us going. Cut it off during the main presentation because it helps the recording. We're going to talk about skimmer basin design this morning. We'll talk about not only basin design for during construction, but also post-construction. This morning's webinar is going to focus on Alabama and Indiana standards. We try to mix that up and change the states we work on each month, but most of the presentation will apply to most areas. So again, I'm going to cut the video off just because that'll help on the recorded version later. All right. If you do have any questions as we go along, please feel free to use the chat. Lynn Ramsey, our sales director, is on here admitting folks and will be helping me monitor that. Again, my name's Jamie McCutchen. Just a little quick intro. I'm a grad of Clemson University. Founded HydroCAD Engineering, which was a land planning site development firm based in Greenville, South Carolina. Owned it for about 20 years. Invented the Marley float skimmer back in 2013, and I'm a licensed engineer in South Carolina, North Carolina, and Georgia. I say all that just to let you know that this is intended to be technical. I've practiced engineering primarily in stormwater for, I guess, over 30 years now, and hopefully you'll find this very informative. So again, today what we're going to talk about is we're going to do just a quick introduction to skimmers or floating outlets. I know depending on where you're located, some places skimmers are very common, others are just now coming in, so we're going to hit the basics. We'll talk about basics of skimmer basin design. Then we're going to kind of switch and talk about using skimmers for post-construction, which may be new to many of you. We're going to talk about how you would model that in HydroFlow if you did want to do that. And then we're going to wrap up and talk about the Rymar water quality filter and a filtration-based design. That's a little bit different way to do pond design than the traditional first flush method. So quickly here, we've got a little poll. So just want to ask the group that's joined us, how familiar are you with skimmers? So you should have that poll up now. If you can answer, this kind of helps me with an idea of who's here and kind of where we are. All right, just about everybody's answered. So looks like we've got a pretty even mix today. So we've got about a third, and a third of new, somewhat, but vary. So oops, I'm gonna share those. So appreciate, you know, that's good to know. We have a wide range for this one. All right, so for those of you that are new to skimmers, you know, we traditionally use some sort of perforated riser. Had a hole either at the bottom or maybe the pipe was perforated, had a check dam in front to help with sediment and erosion control. But the problem was we were pulling most of the discharge from the sediment basin from the bottom of the basin where the sediment concentration is highest. Skimmers came around about 25 years ago now, started in North Carolina, but they intended to float on the surface and take water in from the surface or near the surface and release that water near the top of the water column. That's generally cleaner than the water at the bottom of the water column, and allow more time for sediment to settle to the bottom and get trapped in the sediment basin. There are a variety of skimmers out there. The Faircloth skimmer was probably the one that started most as far as commercial skimmers go. You got the erosion supply or ESC, the IAS skimmer, and then you got the Marley float, which looks a little bit different than the others, as it's probably one of the few that's not PVC based. So this little quick video, this is a skimmer in a basin. This has about 8 acres disturbed area draining to it. You can see it's a pretty muddy, dirty basin. But what's coming out from the skimmer discharge is actually relatively clean water, especially compared to what was in that basin we showed. This was really important. This site was about 100 yards from Lake Hartwell in Anderson, South Carolina. And so the clients definitely did not want to turn the lake, brown or red with that good red clay we have in the upstate. So there's three fundamentals when it comes to sediment basin design. Number one is just basin volume. So that is the volume that you're going to need in your basin. Standards do vary across states. The most common are either 1,800 or 3,600 cubic feet per acre. Alabama's 3,600 cubic feet per acre. We are talking about Indiana today. So Indiana actually requires 5,600 cubic feet per acre, which is one of the larger volumes required. So for example, you had a 5-acre site, and if the requirements was 3,600 cubic feet, as it is in South Carolina or Alabama, that would be an 18,000 cubic foot required volume. And I'm gonna say required a lot here this morning. Some areas, Ohio, Indiana, and Texas, require basins to have a permanent pool volume or sediment storage volume. This is below the invert of the skimmer and is not included when you size your skimmer. So use that required volume, not the actual volume to size the skimmer. Very important if you're have a basin that's going to be your future detention pond. Your basin may have far more volume than required. So just base it on that required volume. The second fundamental is dewatering time. So again, basins work by allowing time for sediment to settle to the bottom. Again, the surface withdrawal takes that cleaner water from near the surface and lets mud settle down and then drains from the top down. The time required is going to vary on soil type. So obviously, if it's a sandy site, it's going to settle much quicker than if you got silts and clays. What we generally see, the most common standard is 2 to 5 days as far as a range of drain time that you can use. That is the Alabama standard is 2 to 5. Indiana is 2 to 3 days. Note that you do need to use some engineering judgment to balance that need for extended times based on your soil types versus frequency of rain events. Like I said, we're based in South Carolina, it's in the southeast. During the summer, we can get those every afternoon thunderstorm. And so if we design the basin to take 5 days to drain, there's a good chance we may get 3 to 5 storms during that time frame and fill it up and kind of overtop the basin. So you probably want to, at least in the southeast, drain it in more of that 2 to 3 day range. The last fundamental is flow rate. So that is simply the basin volume divided by your dewatering time to give you that flow rate. You can use that minimum time for maximum flow rate, maximum time for the minimum flow rate. And you want to base that on whatever your state requirements are. So for example, if you had that 18,000 cubic foot volume for our 5-acre site and drained it in 2 days, you could have a skimmer that would flow up to 9,000 cubic feet per day. Or if you went out to 5 days, you could have a skimmer that's as low as 3,600 cubic feet per day for a minimum flow rate. It is worth noting that a lower flow rate sometimes results in a smaller and typically less expensive skimmer. So if you're trying to be cost conscious on there, you may want to edge towards that maybe 3-day to 3.5-day time frame. So this is a good example of why we focus on required versus provided storage. So this was taken off a set of plans. The engineer had in here to drain the pond in 72 hours or 3 days, had a skimmer size of 8-inch. They did specify a Marley or other approved. Here they have the sediment storage required and provided. Now, in this case, this is in an area that is the sediment storage is equal to the pond storage. So the required volume was 1,754 cubic yards, where the actual basin was 7,500 cubic yards. So, much larger actual than what it was required. So the skimmer that would be needed to drain that required storage would have been a 3-inch skimmer with a 2.5-inch orifice. That skimmer, if it's a Marley, retails for $1,099. Oops, hit for there. So the skimmer that they specified as an 8-inch skimmer, actually the 8-inch skimmer with a 6.5-inch orifice would drain that provided storage at 7,500 cubic yards in 72 hours. That is a almost $5,900 skimmer. So $4,800 more expensive skimmer for that. But the big thing here is that the 8-inch skimmer would drain that required volume in less than 9 hours. And so if our spec, for this area, let's say the standard was 24-hour minimum, By using that large skimmer, we drain that required volume too fast. We don't give enough time for the sediment to settle out of that required volume. So you want to be careful with that. It's a cost thing, but also a compliance thing, and base it on that required volume. So another quick poll here just to help me out. I want to know, where are you located? So I'm going to launch this one. Got a variety of states to pick from here. And just let me know where you are. If you put other, if you would, in the chat, just type in where you're located. It just kind of helps me to kind of know what areas we're getting people to come in from, and then what I need to focus on today. Looks like I've got about 75% have done, so I'm gonna end that and share the results. And we got a wide variety today. Looks like Georgia has the most with 5 people, Ohio with 4, and then other is 5. So, but anyway, appreciate everybody that's joined in today. So, like I said, we're going to focus on Alabama and Indiana today. So we're going to run through kind of those standards. So Alabama has 2 volumes of their erosion control manual. So volume 1 and volume 2. Volume 1 is developing plans, designs, and then volume 2 is installation, maintenance, and inspections. Oops, let's go back here. They do have in the book, it does say the rate of dewatering must be controlled. And so you got a dewatering time of 48 to 120 hours or 2 to 5 days. You do have a minimum volume of 3,600 cubic feet per acre of drainage area. Now, some areas, the volume is based on disturbed area. Some areas is total. So depends on where you are. So in this case, it's the total drainage area. And you've got skimmers are required, and you've got a dewatering time of 2 to 5 days. So just one thing to point out, the Marley float is approved by Alabama DOT. So we got approved back in 2015. So if you are in Alabama, no issues there with using the Marley. Indiana, they have a little bit different standard. So they have 5,600 cubic feet in the dewatering zone. That's the required zone. Or you can calculate a 1-year, 24-hour storm. I'm not that familiar with Indiana rainfall, so I'm not sure, but I would guess the 1-year, 24-hour storm may produce a lower volume than 5,600 cubic feet per acre. They also, in Indiana, requires 1,000 cubic feet sediment storage per disturbed acre. And so this is below the invert of the skimmer, so it's not included in that required volume. Again, this is just in the text, the same thing, 5,600 cubic feet or 1-year, 24-hour storm. Indiana requires it drain no less than 48 or no longer than 72. So a 24-hour range of time you can use there. And then it has the dewatering devices that dewater from the surface. In Indiana, they call them floating outlets. Indiana also does have freezing. So you do want to recognize, if you're in the area, Indiana, Minnesota, Ohio, other northern climate, you may need an alternative for freezing times, and that may be something like a riser with a valve on it. And again, they do have that minimum 1,000 cubic feet per acre disturbed area. That is your sediment storage, and they also specify should not be included in the dewatering storage volume. So when you calculate your skimmer, just based on that 5,600 cubic feet. Again, they have a design sheet, gives the same information. You got your total watershed, disturbed area, dewatering zones based on the total watershed, sediment storage is based on disturbed area. You do have that dewatering time. On the sheet here, you can put in a specific time. We recommend you put in a range. So I would fill that in as 48 to 72 hours. You want to say when you design it what your actual is based on the skimmer you select. But when you're specifying stuff, you want to allow for that range. That allows, if a contractor has another skimmer they want to use, they don't have to hit a precise flow rate with that. Indiana has now released their standards for floating outlets or skimmers. That's in section 708.03 of the IDM manual. Again, they have it specified there. And they also talk about the freezing conditions, so you do alternative practices. So what we typically see on that is you put in maybe a perforated riser, maybe a French drain or something with a valve on it that you can cut the valve on or off as needed if the skimmer has to come out or the skimmer's just frozen. Again, same information we talked about, the fundamentals. dewatering volume divided by dewatering time gives that required flow rate. And then they also have this little table they have on here, which some information that you need to include on your plans. We don't see many people specify the flexible hosing or tube length. That's typically up to the manufacturer. Different manufacturers have different designs on that, but you do want to specify your boom length and boom diameter. The boom, or barrel as it's called, we recommend that this length be that 1.4 times the height of your riser structure. That allows for that 45-degree angle, and that's the same that we have on our details. Just go quick summary here, and that just kind of find this interesting depending on where you are, is we've got 5 different states up here. So we've got South Carolina, Indiana, Texas, Alabama, and Ohio. So you can see the basin volume ranges from that 3,600 to 1,800, Indiana being the 5,600, or you can calculate it. Texas and Alabama also talk about the 2-year 24-hour storm. If you remember, Indiana said the 1-year 24-hour storm. So just the point is the volume varies. So for those engineers that are on here today that work in multiple states, just be aware, got to check that state's regs on what they do. Surface area, some states have an equation. Others just say they have a preferred depth. Ohio has a maximum depth. And some of them have a minimum length to width ratio. So the idea there is you just want to give enough surface area so the pond spreads out, water spreads out, and has time to settle. You don't want a really narrow, deep pond to get your volume versus a wider pond. Principal spillway, either 2-year or 10-year storm. Now, the principal spillway is going to be your skimmer and typically the top of your riser structure. Then most, really all states require emergency spillway, anywhere from the 10-year to 100-year storm, with 25-year storm being most common. Square skimmers required. South Carolina says 10 acres or more, but how it's enforced is any basin with an outlet structure. In South Carolina, you can have a sediment trap, so like a rock outlet for up to 5 acres. So really anything over 5 acres is going to have an outlet structure and need a skimmer. Indiana, basically, again, any sediment basin, so it's got that outlet structure, they want it. Texas, 10 acres. Alabama kind of says when necessary, but again, the way that's enforced typically, at least depending on where you are in Alabama, different parts of the state enforces differently, is if you have an outlet structure versus a rock outlet. And then Ohio is 10 plus acres is required, but most MS4s enforce that the same way as far as, hey, if you've got an outlet structure versus a rock dam, they want to see a skimmer. And dewatering times, again, vary. 2 to 5 days is most common. Indiana's 48 to 72 hours. Texas is 36 to 72 hours. Alabama, again, that 2 to 5. Ohio does allow to go out to 2 to 7, but we typically recommend try to stay in that 3-day target time frame. So one thing about skimmers, people generally think of skimmers as constant head, constant flow devices. Testing has shown that's really not the case. So TRI Environmental did some testing for Georgia whenever they were updating their erosion control manual. Their test tank is 4 feet deep. They did 3 different skimmers. They got a type 2, type 1, type 3. Over here on the right, there were 3 different 3-inch skimmers. If you look at it, the flow rates, 2 of them were very close in flow rate, so about 37 GPM. The third one was nearly double at 70 GPM. From a 1 foot to 4 foot depth, all 3 versions had about a 25% increase in flow rate. Again, 2 of them were close, around 50 GPM, and the other one was about 90 GPM. So the critical thing here to take away is that if you just say generic 3-inch skimmer, you may not get what you want. You may, if you intended to have one that flows at, say, 40 to 50 GPM, and contractor selects the higher one, you're going to drain that volume too fast.
We're getting speaking.
I'm sorry? Todd, you have a question?
Yes.
We don't see the bottom of the slide.
Not sure why that's the case. It's showing on my screen. Are other people having that issue as well?
I see the top of the slide, which has 3 skimmers with the 47.3 number, but the bottom slide is not coming up with the numbers for the drainage
Let
for
me
3-inch
open
skimmers.
my schedule.
I'm not sure why
Exactly.
that would be the case. Is anybody else having that issue?
And my screen is only half coming up. I have no idea why. But
Is there, I'm not sure. I've got a couple other people that have text or chat that said they could see it. So,
okay,
so
go
I'm
ahead.
not sure what's going on with that, but I don't know how to fix it on my side, so I apologize. So,
Okay.
hopefully the recording
And
will
what
will
would
get it
that
in full if you need
replace?
to check it.
Okay.
Todd, you have something? Okay. So again, on the skimmer sizes, you just want to be aware that different skimmers have different flow rates. We have a design tool that builds in the flow rate curve for all the skimmers. So the way it works, and this is available for
Okay.
download.
Well,
We
I
have
am choosing to keep the November 10th appointment.
I'm good. I'm going to mute everyone just to do. I think we've got a little bit of background noise there. So, so again, got a design tool here. So you can put in your date, project name, location, company. You can put in your sediment basin. So, you know, basin 1, 2, 3, ABC, however you have it. We have a check here that we really worked with several states to develop this. Again, I keep harping on this, but the most common mistake that reviewers tell me they see is basing the skimmer size on the actual volume versus required. So this gives you your check for what your required dewatering volume would be. So you edit that, however many acres you have to the basin, and whatever your volume required for that area. So in this case, it was be in a state that was 1,800 cubic feet per acre. So required volume of 13,500 cubic feet. You put in here your minimum and max time to drain. We got 2 to 5 days. Your pond depth. Now that pond depth is going to be the depth of to get your required volume. Okay. If your pond's 10 feet deep, don't put in 10 if you only need 3 feet to get your required pond depth. You'll then have your top length and width and bottom length and width. Now recognize there's very few square or rectangular basins out there. So use your engineering judgment to adjust those numbers. You want the calculated volume here to be within roughly 5% is what we recommend of your required volume. Again, you're trying to hit at least a 24-hour to maybe a 72-hour range of time. So you don't necessarily need to spend, time getting it exact. Once you do that, you're going to go down here to the skimmer report page tab, click on it. It's going to take you to a nice, neat 8.5 by 11 that you can use in your SWIP or on your plans. The top of the sheet is going to give all your information. So it's going to have everything that you plugged in. It's going to give this check right here. So you can see your required volume and your calculated volume are very close together. It's going to tell you the minimum flow rate for the maximum time and the maximum flow rate for the minimum time. And then because it is our tool, it's going to tell you which of our skimmers would be acceptable that meet that time frame. It's actually going to tell you the drawdown time in hours for all skimmers. So you see in this, on that 13,500 cubic foot volume, our smallest skimmer would take 952 hours. Our largest skimmer would drain it in 2 hours. So huge range of time there. In this case, I would probably select our 2-inch with a 2-inch orifice, going to be just under 3 days, which is a good target for most. And that's going to be the least expensive of the options and, also a good time frame. So as engineer, you pick which one you want for your site, but this will tell you all the ones that can meet the time frame range that you specify. We have sediment basin details on the site as well. We actually have 4 different details. So this one would be a temporary basin. So it doesn't have an outlet structure, just has a pipe through the dam and would be dry. This would be a more of a typical riser structure, possibly a permanent basin. And this one would be wet, so we'd have that permanent pool. Over here on the left, you have your criteria for all basins on the site. So you're you got if you have a minimum or maximum length width ratio, if you have sediment storage, again, for a wet basin, dewatering volume required, that's going to be for any pond. If there's a surface area requirement, you can plug that in. Here's where you set your minimum and maximum dewatering time. So you want to plug that in based on whatever state you're in, what the requirements are. And then you have your sediment storage. You want to make sure your provided meets the required dewatering volume, again, required and provided. Drainage area, disturbed area, flow rate, basin surface area, etc. So here's where we get into the meat of it. So you got the bottom of the basin, outlet invert, barrel pipe size. That's going to be this top of the excuse me. The barrel is really going to be here, going out of your pond. Top of your riser, spillway, emergency spillway, elevation and width, skimmer size, skimmer orifice diameter. Here you're going to name your skimmer type. Again, different skimmer types flow at different rates. Is an equal allowed, yes or no? Most of the time that's yes. There may be some select times when it's no. And then your skimmer flow rate. So you're going to go ahead and put in your minimum and maximum range here on your detail for each basin. Now, when you do this, and it goes through the review process, and I'm sure we have some reviewers on here with us today. We typically do. You know, they're going to review that and approve that rate. I mean, that range of time and the rate range. And so when you get to construction, if the contractor says, hey, I've got this skimmer left over from this other project, can I use it here? Well, you know, does it meet this flow rate range? Does it have an orifice configuration that meets that? You know, quick shop drawing type review just to confirm. So what we see most common in most areas is equals are allowed. You know, skimmers are, you know, fairly similar, but they do have different flow rates. So you do want to make sure that whatever skimmer substituted has that correct flow rate. This is our detail. So a couple of things really quick. Our skimmers have these orifice plates to adjust the orifice size. So some skimmers kind of have a different ways to do that, a disc or cut or different method of it. We just have standard sizes. This box up here, I know you can't read that, but it is the testing, third-party testing of the flow rate for each orifice size. Again, the most common question we get is the barrel size here. Again, we recommend 1.4 times the height of the riser. That lets the skimmer come up to the top of the riser at about a 45-degree angle. We do also typically suggest a minimum of 8 feet for your riser, I mean, for your barrel there. You know, let's say your riser was only 2 feet tall. If it's a really, you know, wide, shallow pond, well, you probably want more than a 3-foot piece of pipe there. You want it to stick out in the pond a little bit more, at least 6 feet. We kind of suggest 8. So our newest thing is on our website. We have a skimmer calculator tool. So if you go to the website, you can find this. You plug in your basin name here, your required pond volume, set your minimum and max time to drain. It'll tell you those minimum and max flow rates. And then it will tell you which of our skimmers or skimmer size and orifice size fall within that range and what the approximate drawdown time of each would be. Then you can say, hey, you know, for this job, I want to pick, let's say in this case, I wanted to pick the 3-inch with a 2.5-inch orifice, hit the download button, and it's going to take you over to, well, I picked a 4-inch with a 2.5 for the example. So it's going to take you to this detail. It's going to fill it all in for you. So again, this gives you the skimmer size, the orifice size, the drawdown time, what the flow rate of this skimmer is. Now that's the peak flow rate at a 4-foot depth. We kind of use this as a simplified tool. The required pond volume is going to be here and your time to drain. So it gives you all that information on the detail so that, you know, if another skimmer was used, they have that information they need to substitute. So that's been received very well. A really quick and easy way to get a PDF. You can download it, pop it right on your plans. We also have on there a CAD file you can download and then edit manually if you'd like to. A couple of quick things here. So this is a couple of photos of skimmers, you know, in basins in the field. This one, pretty well done pond. You can see it's tracked in the sides. They've got their baffles in, got the riser structure in with trash rack. Thing I point out here is the contractor did not put a depression here when they put the stone pad in. And so when they did that, they raised the skimmer up about 8 inches off the bottom of the pond. So this pond, if it's intended to be dry, is always going to have a little pool in it that is not going to be drained by the skimmer. So if you're trying to get grass to get established and get the pond stabilized, you want to make sure to put that depression in. This is probably the worst install we've seen. This was an inspector, I think out of Ohio, sent this to us. You know, there's no flexible coupling here. If you look closely, that valve's open. Skimmer's kind of lopsided because it's sitting on a check dam. So just, you know, poorly installed by the contractor there. And then, you know, this I'm not sure how it happened. You know, this pipe obviously is not near long enough for this. They put it in upside down. We do have a label on the top of all the skimmers with a QR code that goes to an installation video and says this side up. So but sometimes things happen in the field and contractors do contractor things. This is one too, has some vegetation growing out of the skimmer. So skimmers are not maintenance free. They do require some maintenance, some more than others, but in this case, the skimmer had a big root ball inside of it. So the pond was not draining at all like it was supposed to. All right, that's kind of wrap up on our skimmers for during construction. If you do have any questions, please put them in the chat and I'll be glad to take a look and answer as we go. So now we're going to jump into permanent use of skimmers. One more question for you here. So just simply, have you ever considered you or ever used a skimmer for permanent use? We're starting to get more yeses in here, so that's exciting for us. We've been pushing this for quite a while. About 75%, so I'm in that. I'll share it. So we had 3 people that said yes, that's great, and we got 6 that said that considered. So nearly half have either have at least done it or thought about it, and another 60% have said no. That's pretty typical. I actually a little better than typical. We're starting to get more in that considered or yes column. So let's talk about why you might want to do that. So let's focus on a dry detention basin. Dry detention basins are probably the most common B&P out there. And so if we had a dry detention basin, typically what happens, you're converting it to post-construction. You're going to remove the skimmer. You're going to put in some sort of low flow orifice installed at bottom to release that first flush, assuming water quality is required, and you're doing a first flush method. And you're going to have some sort of guard or filter to reduce the clogging. So, but what are we doing? We're reverting back to that old sediment basin standard where we're discharging or pulling our discharge from the bottom of the basin where the pollutant load is highest, because the whole intent of basins is to have the pollutants settle to the bottom. So kind of reversing back to where we were in the old construction ways. So, sediment's going to reach the outlet, right? Larger particles are going to settle out or maybe captured by a forebay, but those sands, silts, and clays are going to continue to flow down towards in this case, not river mouth, but the outlet of the pond. And so if you had a cross section of the basin, where everything's coming in, it's all pretty dirty. But as you get towards the outlet, that top level is a lot cleaner than the bottom because the sediment has settled out. Again, basins are relying upon that natural settling of the sediment particles. Those skimmers are releasing that cleaner water from the surface, widely accepted and proven to be very cost effective for construction. So doesn't it just make sense that we consider using those same methods for post-construction water quality? So this is a site that was done in Simpsonville, South Carolina. It's kind of our playground or R&D area. So we had to retrofit this pond. So this pond had a 2-inch low flow orifice. This picture on the right, that 2-inch orifice is about 6 feet below the now bottom of the pond. So it had clogged up for a long time, and a lot of debris had built up in the basin. So we were fixing this pond and didn't want to go back with a 2-inch orifice, so went back with a 5-inch skimmer instead. This is once it was installed, sort of stabilized. Now, would have preferred the contractor had put it in right at the bottom of the pond, but they, probably had to core that in, and just getting the core in, had a hard time getting there. So it's 6 inches or so off the bottom. This basin, that riser, those are 6-foot riser sections. So these are the old orifice holes. We redesigned this basin. Again, it had a 2-inch orifice down at the bottom, 6 feet below the now bottom of the pond. Replaced it with a 5-inch skimmer, and had closed these orifices and added some other ones here. So about a year later, the owner now is maintaining this pond, and they had cut it and got a huge thunderstorm that washed all the cuttings, down to the bottom of the riser. But you see the skimmers here. So you can imagine if all that debris was in this basin and had a 2-inch orifice just, unprotected here, or even had some minimal protection, good chance it would clog up, and it would be very hard, if not dangerous, to clean out. With a skimmer in place, you can't see the rope on it. They were able to just kind of pull on the rope if it did clog, but get it there. Or even worst case, if they forgot to put the rope on it, they just kind of float out on the surface to get to it if it did clog. So much safer, much less maintenance required to keep the pond functioning properly. So if you're going to use the skimmers, you have to know how to model them. So I'm going to run through a little quick how to model in HydroFlow hydrographs. Now that HydroFlow is part of Civil 3D, that seems to be the most common hydrology software, but the methods we go through here will apply with other hydrology software as well. So this is a site that was actually in a municipality that required quantity control during construction. So we're going to be looking at a during construction site, but it does require quantity control. So got about a 5.5 acre site. 3.4 acres are not being disturbed. 2.2 are being disturbed. Going to this little sediment trap here, which is draining out to our study point. Pre-development, again, 5.5 acres, curve number 59, time of concentration, about just under 20 minutes. Post-development, the undeveloped portion, undisturbed, is the same. The developed portion is 2.23 acres. Used a curve number of 86 for a bare earth disturbed condition. Time of concentration for that portion is now down to about 7 minutes. So when you build in your basin, what you want to do is build in a stage so that you can input the flow rate. So here I put in a 0.1, 0.3, and then every half a foot up to 4 feet. This basin just happened to be 4 feet deep. And when you do that, you'll be able to take the flow rate off the skimmer and plug it in. So when you go to build your outlet structure, you've got your barrel coming out of your pond, in this case, 18-inch pipe. We had a 6-inch orifice about 1.75 feet off the bottom of the pond. Our riser structure was 3.6 feet tall and had a rectangular weir, the top 0.6 feet, 1 foot wide rectangular weir. And here's the kind of the secret sauce is this user defined column. You plug in the flow rates off of the skimmer details into this user defined. So again, we built in our stages here, 0.1, 0.3, 0.5, and every half a foot to 4. And then just simply manually plug that in the user defined, and that builds in that skimmer flow rate curve into your hydrology so it can model it accurately. Now, what happens if your pond's over 4 feet deep, which probably most permanent ponds are? So you can do it a couple of different ways. You can either just maintain that flow rate at the 4 foot depth. You can use the last 3 data points and extrapolate it out. So you can see there's just a slight increase from 3, 3.5 to 4. Or if you got a deeper pond, let's say your pond's 8 or 10 feet deep, you can go back to our tool. We looked at it before and put in that total pond depth here. So that we put in 8 feet. Our tool breaks that, whatever the pond depth is, into 20 different increments, and it calculates the flow at each incremental, stage. So, but it'll give you the flow rate in CFS for whichever skimmer you want to try at each one of these 20 increments. So, you're going to probably pick ones that are close to a foot or half a foot intervals and plug that in. Now here I'm only showing our 2-inch with a 1/2-inch orifice, so you're not seeing much change, if any, in flow rate. But as you get to the bigger skimmers, you're going to see a much bigger change in flow rate over that depth. So again, breaking that water level into 20 different increments, and then it'll give you the flow rates you can use and just take it off the spreadsheet and plug it into HydroFlow. And then when you do that, your schematic's going to look something like this. So you're going to have your riser structure, your rectangular weir, your orifice. Normally you would have that low flow orifice down here at the bottom, so a 3-4 inch hole or something. In this case, you don't have that. That's because it's user defined. But when you look at your stage discharge curve, you can see your flow rate here. This is coming from the skimmer flow. And that's where your orifice kicks in, your weir kicks in, riser kicks in. So any questions on HydroFlow? I will mention we do have some tutorials on our site that go into more advanced and kind of go a little slower on this. We only got an hour this morning, so I'm trying to fit a lot in, so going a little quick. So, but it is there available if you need it. So the last thing here we're going to talk about is our advanced skimmer modeling and filtration-based water quality. So the idea here is we designed a filter to go around our skimmer. So the outer edge is a polyethylene fabric. It's just basically a screen. It's like a mirror-fied geotextile. The inner is a non-woven called Adsorbate, which is great for sediment. Also helps with TSS, with hydrocarbons, some help with metals. And then the idea is the skimmer is pulling the flow through those filters to get to the skimmer to get discharge. The filter is open on the bottom. It hangs about 3 feet deep. So the idea is that if water is below that 3 foot depth, there's not enough turbulent force to bring it up and get discharged by the skimmer. So we're filtering the top 3 feet, allowing gravity to do the job below 3 feet. So go back to that pond we showed you earlier. That same riser structure. We've put in a skimmer out there that's got our filter prototype around it. So this was maybe our 6th or 7th different prototype. So 2-stage system. We used a turbidity curtain that had a filter in the side, had a screen. It's not a solid turbidity curtain. It allows water through. And then there's your non-woven. It looks kind of like this. You can see there's your screen material in the turbidity curtain. And then the inner one, what we ended up doing is actually have 2 layers of fabric. We put basically 6-inch slits or panels there, and we offset the panels 3 inches so water kind of weaves through that fabric, creates more contact with this material. Kind of, I guess, referred to as somewhat sticky, kind of grabs the sediment particles and other polluted particles as they come through there with the contact time. See here, we had this prototype out there for about 2 years being monitored. We had a time-lapse camera set up to keep an eye on it. This picture on the left, you can see turbidity is a lot lower inside the filter versus outside. And then this picture on the right is the actual outfall. So pretty clean outfall, water coming out of this pond. So after about 2 years of making sure that it was working, we decided to have third-party testing done. So we had it tested, and we got 90% TSS removal, which obviously that's pretty high. Most places require 80. There's some areas require 85. This system, skimmer filter system, got over 90% TSS. Now, important to understand how we got to that test and how the test results were done. Number one, it was done to an ASTM standard. So many of you may not be aware, ASTM is now working on stormwater and sediment erosion control standards. So this happens to be ASTM C1746. It's a standard test method for sediment retention devices. The other thing is, when you have a pond, typically you have a variety of things that contribute to the sediment removal. You've got a forebay, you've got travel distance, you may have vegetation, you got a lot of different things that can assist in that pond functioning to remove the sediment. It would be very difficult to determine what portion of the removal came from each part of the pond. So what we did is we set this tank up to simulate a pond, but we put the sediment laden water in right at the filter. So we negated the forebay, we negated the travel distance. We just said, hey, how under these sort of worst case conditions, how will this system perform? And so, the water had to come in, go through the 2 filters, and then get to the skimmer, or once the tank got over 3 feet deep, it could come underneath. So, and those 2, we tested 2 different versions of that, and both of those got over 90%. So we've now, this goes back to that same basin. We've put in what we call our commercial version. It's now ready for sale. This is that pond. You can see, kind of it's really steep, doesn't stay wet. It does drain out, over time, but it takes a while to drain sometimes. This pond is in a commercial watershed of about 40 to 50 acres. It's older commercial development, so there's almost no other stormwater management in place, which is probably why this pond got so built up with sediment when it did. But got it out there, got a time-lapse camera set up, and continue to monitor that. It's been out there now for about a little over a year and a half, and we'll keep it out there, long. So this is a little quick time-lapse video. You can see there's actually a beavers invaded the pond and started building a dam around the outlet structure. But fortunately, the skimmer is still floating and working. So this is over a couple of days of rain. So pond filled up, it's draining back down. Now we'll say we have sized this skimmer to still meet the minimum 24-hour drawdown time of the water quality volume. We haven't gone back and updated the permit to recognize and benefit of the filter. It's just an extra here. We just, are using that to drain. And so you can see over time that skimmer slowly draining the pond down, allowing time for sediment to settle. It's also having the benefit of things going through the filter. So what are some benefits to filtration instead of settling? So number one, when you use it with a pond, you've got a large containment volume to reduce the maintenance frequency, and you can treat larger drainage areas. Number two, there's an excellent potential to retrofit older basins that did not include water quality benefits if the peak flow rate can be maintained. So if you can use filtration and you don't have to have that first flush volume released slowly, which increases the volume of your pond, you can go back and very easily replace that low flow orifice with the skimmer filter combination and add water quality to basins that don't currently have water quality, assuming the skimmer can handle whatever that low flow rate, typically 2-year storm rate is. So I'll mention we just met with Forsyth County in Atlanta. I think we've got a few people in here from Georgia today, and they're looking at potentially using this technology to retrofit some county-owned basins to help meet some of their MS4 requirements. They're excited about the potential of retrofitting basins and adding water quality to it without having to change the size of the basin. Other thing is filters and ponds can be relatively easy to access and maintain, especially when compared to systems that use underground vaults or require confined space entry. Some other benefits are the peak rate of discharge can be based on the filter treatment flow rate up to that first quantity storm event. So in most areas, that's a 2-year storm. Some areas may have a channel velocity or I forget what they call it. Different things have a lower storm event that has to be maintained. But whatever that storm event is, if your filter can handle the flow up to that rate, then you can release at that rate and not have to use the first flush method. The other big thing here, this is a big one. Filter treats 100% of runoff from storms up to the peak rate of the filter. So, let's get realistic. Using the traditional first flush method, that's typically a storm event of about a 1.5 to 2 inch storm. So, what happens when you get a 1/4 inch of rain that goes into your pond? Well, if it goes over a couple of hours, it probably goes straight in, straight out. And so if all of our treatment is based on ponding to allow for settlement and we get no ponding, then, what kind of treatment do we get? Basically none, right? And so with a filter, all that water's got to go through the filter before it can get discharged. So you're treating the small storms. And then if you can design your filter to handle a flow rate higher, let's say up to the 2-year storm, now you're treating up to that 2 years. So you're treating from the trickle all the way up to the 2-year storm event or whatever storm event your filter's handling. And then the third one is your filtration media can be customized to target specific pollutants of concern. I mentioned the media we're using already has benefits for hydrocarbons and metals. We are talking with a couple of other media folks about ways to take out nitrogen, phosphorus, PFAS, variety of pollutants are of concern in different areas. So, very versatile system that can be customized to meet specific pollutant concerns in different areas. So, if we combine the skimmer with the filter, what's the benefits to that? If we could just put a filter out in the pond, but if we want to combine it with the skimmer, now your skimmer is your flow control device, right? The filter is going to be hard to control flow with a filter, but the skimmer is a flow control. So you can now size the skimmer to handle the peak rate for the lower storm events. The skimmer is going to increase the efficiency of the filter because now it's not pulling off the bottom. Let's say that we had a French drain down here with a filter at the bottom. Well, that's going to get covered up really quick by sediment if it's doing its job. But because our skimmer's raising the filter up and our filter staying near the surface, the filter doesn't have to work as hard because that water is not as dirty and it's not getting, caked up by the sediment. And then it's pretty easy to access. You can get to the pond. If it's a dry pond, just let it drain out and get to it. If it's a wet pond, you just pull it over to the side. So there are some challenges to using skimmers with filters. Number one, they're going to clog over time. They're going to require maintenance and periodic cleaning or changing. Currently, we're recommending replacing the filter every 2 years. That's based on our prototype life and how long it did in the field. Number two is you've got to have a skimmer that's durable and lasts more than a few years to be suitable for permanent use. Our skimmer's always been HDPE. It's always been promoted for permanent use. There are now other skimmers coming on the market that are more designed for permanent use. So it's a trend that's coming along. And then the third one here, and this is a big one, there are no established standards for basis of design and permitting based upon combining the pond and filter. We are right now in the process of working with NJCAT to confirm some protocol and methods they want to see. Our next step in our testing is going to be to do that testing to NJCAT protocol, submit it for verification, certification by NJCAT. So that will definitely help with the widespread acceptance. Currently, I can tell you Georgia has been very open to accepting this. Pennsylvania, we've talked with DEP there, and we meet standards for there. Now, the review authority, local MS4 conservation district needs to understand it. Few other areas have given us the okay. So if you're an engineer and you're like, hey, I kind of like this idea, I'd like to try it. Or if you're an MS4, would like more information on it, please reach out to us and let us know. If you're the engineer, let us know where you're based and where the project is that you're going to be looking at. We will get with the MS4, make sure they understand it and they're okay with it. Believe me, as a consulting engineer, the last thing I want to do is spend the time and effort to put a design together that gets rejected by the MS4 and it slows down my permitting. So let us know that and we'll work with you. And we can tell you what areas have approved it already and what areas we're working on. So, but most, I would say in general, unless they have a set list of proprietary products that has a requirement such as NJCAD approval to be on it, majority of MS4s have said they will consider it on a case-by-case basis and are very open to it, especially once they understand some of the benefits of it.
Can you explain MS4, which is MS means the municipal standards?
MS4 is a municipal separate stormwater
Okay.
system. So that's the city county review agency that is approving most plans. So
It's a city, county, you said?
yeah, it'd be a city, county, it could be a state agency, could be multiple counties. It's just in most areas they're referred to as MS4s as the review agencies for stormwater. So
MS4 or it is MSSSS?
yep,
Is municipal sediment
municipal
control?
separate is municipal separate stormwater system.
Okay, municipal separate stormwater system. Okay, thank you.
Yep, I think that's 4S's. Yep. So following up here, so the last thing we got is just a quick comparison of our first flush model versus filtration based model. So we're going to look at a sample site of 5 acres. It's got a pre-development condition, CN of 55. Post-development, we're going to say we're going to commercial little center curve number 92. So pre-development flow rates, 2-year storm is going to be 0.72, assuming a time concentration about 50 minutes. 10 years, 3, you can see the 25 and 100. We're going to focus on the 2-year and water quality event. So next thing we want to do is we want to determine our water quality and post-development flow rates. So based on the 5-acre site, assume time concentration of 10 minutes. So in South Carolina, the water quality storm event generates 1 inch of runoff. Georgia's 1.2, Indiana, I think it's 1.5. I didn't look up Alabama, so I'm not sure. I think it may be 1 or 1.2. So anyway, whatever your state water quality volume is, you're going to trial and error to come up with a storm that'll generate that. So in this case, for a 1 inch runoff volume, that equates to 18,150 cubic feet. And using trial and error and HydroFlow, I came up with a 1.73 inch 24-hour storm that would generate that volume of runoff. So that is 7.2 CFS and then 19.72 for a 2-year storm. And you can see our 30, 25, and 100-year all went up substantially. So most engineers have a spreadsheet that looks something like this. So it kind of calculates the orifice size to drain that volume, required volume over a certain time frame. So you've got a contributing area, so you come up with that volume. Now, interestingly, for the spreadsheet, it's minor miracle that volume appears instantaneously in the pond. Poof, it's there, right? Obviously that doesn't happen, but that's how the spreadsheet works. You take that volume, drain it over 24 hours, come up with an average flow rate. Then you kind of look at an average head equation, come up with an orifice size. So, theoretically, we need a 0.21 CFS flow rate to drain that volume in 24 hours, which will be a 2.6 inch orifice. So ran a hydrology model here, put in a 3-inch low flow orifice with a trash guard at the bottom, another 3-inch orifice 3 feet above for our 2-year storm, and an 8-inch orifice for the 10-year storm, and then the riser. So it takes 3 feet in this hypothetical pond to reach that water quality volume of 18,150 cubic feet. So when we run through our hydrology, we're going to release that water quality at 0.25. We were shooting for 0.21. It gets to a peak elevation of 12.5, half a foot below, so we're not using a half a foot of the volume. And we only use 10,700 cubic feet in the pond. Again, our spreadsheet assumes it magically appears instantaneously, so it uses that full volume. Reality is you've got inflow, outflow hydrograph, and you're only using about 2/3 of that volume to actually detain that water quality event. 2-year storms, 0.81. Again, our pre was 0.72. Depending on your location, your reviewer may go, got to get it down to 0.72. or they may allow a slight increase for the 2-year storm. 10-year, 25 were detained below pre. So the alternative here is to look at a filter design with a skimmer. So again, we're going to use the skimmer to control the flow rate. We're shooting for that 0.72 CFS. So a 6-inch skimmer Marley float with a 6-inch orifice has a flow rate of 0.778 CFS. So we're going to try that one in the model. This is the detail for the filter. One thing to point out, the filter sizes are based on testing the 4-inch with a 4-inch orifice, and we have to maintain the flow rate per square foot. So maintain the area of the filter so we got a flow rate per square foot that we're allowed to have, and we had to make sure we get enough area of the filter to meet that. We also have a flow rate per linear foot of the filter. So we designed this so in case the filter were to completely clog, we don't want the water coming under the filter at too high of a rate. So what that does is we have 2 different lengths. We have an outer, we have an L1 and an L2, and we have an inner and outer of both. The reason for that, this pipe, you really don't want it to be more than 20 feet. Assuming your riser structure is probably not more than 12 or 14 feet, maybe 15 feet tall, 20-foot piece of pipe will work there. When that riser comes up at a 45, where the skimmer comes up at a 45-degree angle, there's only going to be 10 feet between the skimmer and the riser structure. So we don't want more than 10 feet here, because then the filter is going to start hitting up against the riser. So you'll see the maximum L2 on the outer skirt is 16 feet. Because our max 8 skimmer flows at almost 2 CFS compared to our 4-inch skimmer at just 0.4 CFS, that means the L1 has to get pretty big. So it's up to 46 feet. Now we're hoping when we do our NJ-CAT testing, we're able to reduce that down. I really think probably a 12 by 12 would actually work well, but we have to go with the testing we have currently to date. So this is the pond detail for the filter. And then, so if we run that through the hydrology program, what we're going to find out is our water quality event now flows out at 0.70 CFS. So it's nearly 3 times what we were flowing before. And our 2 years, and it only uses 7,600 cubic feet of volume. So again, the skimmer is controlling the 2-year storm. So we don't have that other 3-inch orifice. We just have the skimmer attached here. And our 2-year storm rate decreased down to 0.78 CFS. And then we've got an 8-inch orifice, and then the riser structure controlling the 10 and the 25. So you've used really a third, or just over a third of the required water quality volume based on the traditional first flush method. And that is treating that. You're also now treating the full 2-year storm event because it's all going through the filter and skimmer combination as well. And so if you compare those, skip that slide, go to the next one here. If you look at a comparison of traditional pond storage versus skimmer pond storage, the water quality volume uses 30% less, and then 2 and 10-year use 14 and 12% less. So your pond size reduces substantially, but you're also treating more of the storm event. So in summary here, skimmers are less prone to clog than the orifice located at the bottom of the pond. They're going to require less maintenance. They can be a very effective way to retrofit existing basins to reduce maintenance, and you're going to enhance the water quality even if you don't add the filter. But adding the filter is going to get you all the way there to the water quality portion. Surface straw is going to release that cleaner water from the basin. So again, even without the filter, if you're just doing it from a maintenance standpoint, just to add a skimmer, you're going to see improved water quality. We haven't done any testing on that, so I can't give you any rates, but it'll do that. The use of the skimmer with the filter has been tested per ASTM standards to meet 90% TSS removal. The skimmer with the filter is going to treat more of the annual rainfall. Again, we're going to treat those small storm events, those trickles, they got to go through the filter. And then the larger events, whatever's managed by the skimmer, is going to be treated as well. And you're going to have a reduced pond size of 15 to 20% over the traditional first flush method. So last poll here, and this will be really quick. Now that you are familiar with the benefits, what happened? There we go. Would you consider using a skimmer for permanent use? I knew it. We always have at least one that still says no, and I'm okay with that because you're the engineer. You get to make that decision, or you're the MS4. majority are saying maybe or yes. So just because we're running low on time, I'm going to end that now. So again, usually have at least one person that says no, and there may be a variety of reasons. I will say if you're in a northern climate and frozen conditions are a big issue, it may not be the right product. That's just one limitation of the product. So, all right. So we are at end of our hour, so I'm going to fly through the rest of this. This is just a little bit about us. This is our website. I mentioned before we have a resources and training. So all of our webinars, I'll say not all, our last maybe 4 to 6 webinars are on the website. You can select it here. We also have a training series. So what we've talked about today is broken down into 5 to 15-minute segments, get into a little more detail. So and also we have some things we didn't talk about today, like if you're in an area that uses SEDCAD, which is kind of limited, but where you are there, you need to know how to model a skimmer in SEDCAD. We'll walk you through how to do that. This is our engineer spec pack. So if you go to our design spec sheet page or install page, you download this. It's a zip file. It's going to give you everything in one easy download. So you're going to get our skimmer details, design tools. You'll get the test data. You'll get supporting information, maintenance recommendations, that kind of stuff. You'll get sediment basin details. You'll get the water quality based details, design guidance, kind of step-by-step walk you through how to design for water quality, the test data and supporting information. So it'll organize all that for you, 3 separate folders. Put that wherever you save your details on your server, and it'll all be there, easy to use. Again, we have a state-of-the-art design. It's an HTP product, polyethylene float, stainless steel, aluminum fittings and parts. It's UV resistant. We say it's virtually indestructible. We've had these things get blown out during a hurricane, go downstream a couple hundred yards, picked up and put back in. We've always intended it to be part of the permanent outlet structure, and it's gotten really no moving parts. You have one little piece that pivots, but other than that, it's nothing to get stuck. Our shielded orifice here prevents clogging. So, water comes in under the orifice. So anything floating debris stays away from the orifice. Flow is going to, this debris guard, depending on the size of skimmers, 4 inches to 20 inches below the surface, and traps the floatables. It does work in mild frozen conditions. You get, 3 or 4 inches of ice, it's going to still work. You get up 6 inches to a foot of ice, it's probably going to freeze there in the basin. We talked about our orifice plate, how it works. So this little quick video here shows how it's just a piece of EPDM rubber, different size orifices, got this little metal nub here in the middle, make sure it's put back in place, it's held in there securely, and that also makes sure that the orifice is centered over the outlet pipe. Each model is going to give you at least 3, if not 5 flow rates in one device. They've all been third-party tested to verify the our skimmer was redesigned back in 2019. When it initially came out in 2013, it was a little top heavy. Now it always floats level. Hopefully nobody ever does this to your skimmer in the basin, but if they do, it'll pop back up and always float. 6, 8, 3, and 4 all have a custom float. Our 6 and 8 have handles that make it a little bit easier to move around. They are heavy. They weigh about 200 pounds. So it takes 2 people to set them in the pond. We do have 8 versions. Like to point out, we have 2 different 8-inch skimmers. Our standard 8-inch uses a 6-inch pipe to connect to the riser, and our 8-inch with an 8-inch pipe, it has the highest flow rate of any skimmer out there, almost 2 CFS, 1.8 CFS, which is about double most other 8-inch skimmers. And like I said, flew through that one. So you can, if you need a PDH certificate for today, please email us at info@rymarwaterworks.com. Lynn, Richard, or Kelly will get back to you with that. If you have any questions, please ask. We really do want to be a resource for you. If there's any other questions in the chat, I don't see any more right now. Lynn did put up a link to our website there, so you can click on that to get there. But appreciate everyone's time today. And if we can be of any service to you, or if you have any questions, please let us know. If anybody has any questions now, I'll be glad to answer them.
Thank you.
All right, I'll stop the share. I'm going to end the recording.